Hey, student, how are you? Welcome to our session on solving systems using elimination. We're going to take a look at 4 examples of solving linear systems. First, by adding the 2 equations together to eliminate a variable. Number 2, subtract to eliminate a variable. Number 3, we'll have to multiply one of the equations before we add or subtract to eliminate a variable. And number 4, we'll have to multiply both equations in order to add or subtract to eliminate a variable. Number 1, let's solve the system of linear equations. And our second equation. Elimination, our goal is to eliminate one of the variables by adding or subtracting the 2 equations together. Notice, we have minus or negative 2y and plus 2y. We can add these 2 equations together. When we add these 2 equations together, minus 2 or negative 2 and plus 2y give us 0. They cancel out or are eliminated. Let's add the rest of the equations. 3x plus 4x gives us 7x. And 6 plus 8, we get 14. Let's finish solving for x. We'll divide by 7. And we get x is 2. This is the x value of our point of intersection, the point where these 2 lines cross. We need to solve for the y coordinate. We're going to substitute x equals 2 back in to one of the original equations. I'm going to use the top equation. Substituting 2 in for x and solving for y. We'll subtract 6 and divide by negative 2. And our y coordinate is 0. The solution to this system of equations is the point 2, 0. This is the point where the 2 lines cross, if you were to graph. Let's take a look at number 2. Let's solve the system of linear equations. This time, notice, we have positive 2y and positive 2y. If we were to add these together, we would get 4y. So we're not going to add this time. When signs are the same, we'll subtract. Subtract. What I like to do when I'm subtracting to eliminate, I like to put parentheses around the bottom equation so that I remember to subtract. 8x minus 7x is 1x. 2y minus 2y is 0. They are eliminated. And 30 minus 24 is 6. And we already have our x coordinate for our point of intersection. Now we have to solve for the y coordinate. We'll substitute x equals 6 back in to one of the original equations. I'm going to use the top equation. We'll solve for the y. Subtract 30 minus 48. You can always use a calculator. And divide. And this is our point of intersection, the point where the two lines cross. Example number 3. Number 3. Let's solve the system of equations. Sometimes when you don't have coefficients, the number in front of the variable that matches up, like we had negative 2y and positive 2y, or positive 2y and positive 2y, sometimes you do need to multiply one of the equations so that we can use elimination. I'm going to multiply the bottom equation by 4x. 4. Multiply the bottom equation by 4. When you're multiplying the bottom equation by 4, you need to make sure that we multiply every term on both sides by 4. And now our bottom equation becomes and now we have variables that we can eliminate. We're going to add the two equations together to eliminate. Adding the two equations, 9 plus negative 12, and 9 plus negative 24. You can always use a calculator. And divide. 2 negatives make a positive. Now we need to substitute y equals 5 back in to find the x coordinate of our point of intersection. I'm going to use the top equation. It's a little bit shorter. Substituting 5 in for y to solve for x. And we'll add 15, negative 6 plus 15. And we have our x and y coordinates for our point of intersection. 9, 5 is the point where these two lines cross. Let's do one last example where we have to multiply both equations in order for one of the variables to eliminate. Last example. Let's solve the system of linear equations. There's a couple different ways you could solve this. I notice that if I multiply the top equation by 4 and the second equation by 7, I will end up being able to eliminate the variable x. What did we say? Top equation is being multiplied by 4. Multiply by 4. Every term, both sides. And the bottom equation will multiply by 7. All right, let's see here. Negative 7x times 4, we get negative 28x. negative 8y times 4, and 9 times 4. Remember to multiply both sides of the equation. And the second equation, negative 4x times 7, we get negative 28x. Ah, there we go, negative 28x, negative 28x, those will eliminate. We'll finish multiplying by 7, 9 times 7, and oh boy, negative 22 times 7. Numbers are getting big. You can always use a calculator. Now, we can eliminate our x variables. We are going to subtract these two equations carefully with all these negative signs. Subtract. Negative 28x minus a negative. Go ahead and do it in your calculator. Negative 28 minus negative 28. You get 0. So these are eliminated. Negative 32y. Negative 32y minus 63y. You can always use a calculator. And then 36 minus negative 154. And then we'll divide 190 divided by negative 95. And we get y equals negative 2. Now we need to substitute y equals negative 2 back in to find the x coordinate of our point of intersection. I'm going to use the second equation. It might be a little easier. You can always use the top equation to substitute back in. Solving for x. Negative 22 plus 18. And divide. Negative 4 divided by negative 4. Negative divided by a negative is a positive. And we have found our point of intersection, the point where these two lines cross. And that concludes our session on solving systems using elimination. I'll see you next time.